Okay, so welcome back. I'm happy to see and present you Iulian from Adobe. And I'm very happy to hear about the topic vCluster. And yeah, the floor is yours.
Yeah, thank you. Thank you for this introduction. And before starting, let's give a round of applause for the speakers before and for all the organization. Okay, hello everyone. My name is Iulian. I work as a cloud software engineer at Adobe. And today, I have the pleasure to present you a project that leverages the power of vClusters in the context of CI testing. Before getting into the details, let's structure the presentation a little bit in 4 main chapters. First, we'll get in touch with the CI testing problem and we will set the objectives. Then we are going to see what is a vCluster with its benefits. We will then continue with a deep dive into an end-to-end PR testing workflow, and we are going to end up this presentation with some benchmarks and conclusions. Is everybody comfortable with this agenda? Okay, thank you. Let's kick off our journey to mastering CI testing with the first chapter, namely introduction. Let's start thinking about different ways or solutions when it comes to testing code changes in a project. We have 2 main options. Option number 1, we can do this, or we can do something more professional like this. And here, we can build a pipeline with different stages in order to validate several parts of our code. And here I'm thinking about tests like unit tests, load test, functional test, or some end-to-end tests. It's obvious that you can find the bugs directly in production, but I think it's better to catch them before they cause any trouble, right? And for this, we need to test the changes somehow. As we all of us know, classic CI means that for each code change, for each pull request, you spin up a new clean cluster, right? But for educational purposes, I consider that we have a better setup for CI, where we keep a pool of CI clusters already built, which are waiting to be used for testing. When a new PR is created, one of those pre-built clusters is picked up and used to test the changes from the given pull request. The testing process starts, but of course we want to maintain a fixed number of clusters in the pool. And for that, we need to create another cluster and add it to the pool. It's obvious that this method works, but it has 2 main disadvantages. The first one is that long spin-up time results in a slow development process. And the second I'm thinking of is that unused clusters will remain in the pool, leading to higher costs. This slide describes the process is currently being used, but now let's see if there is room for further improvement. Instead of spinning up a new cluster for each PR, as we saw earlier for traditional CI, let's suppose that we have the possibility to create an isolated testing environment to test our changes with a reduction of time of 80%. Basically, when a new PR is created, you set up some sort of testing environment similar to provisioning a namespace and deploying some Kubernetes objects in there, and just like that, in a matter of moments, you have a fully functional cluster deployed in the host namespace where you can test your changes on. Basically, that's the power of vClusters. But before diving into the magic of vClusters, let's play a really small game together. Let's raise our hands for the following questions to see how familiar we are with the Kubernetes ecosystem. First question, how many of you know what is Kubernetes? Okay, expected. How many of you have used namespaces for isolation? Not bad. And the last one, how many of you have used vClusters before? Okay, some hands in the back. I think the pattern is pretty clear and expected. Kubernetes, everybody. namespaces fewer but still a good crowd. For vClusters, definitely fewer hands, but let's dive in and explore it. Okay, as a summary, we discussed some introductory things. We have set our goals for this presentation. Now it's time to explore the power of vClusters. And I think a good way to understand something is seeing it in action directly through a demo. Let's check out this short presentation about virtual clusters created directly by the team behind vCluster.
Meet Lucia. Lucia is part of the platform team at a large company. Her team is responsible for provisioning and maintaining cloud infrastructure and tooling for over 1,000 software engineers. One day, the machine learning team wants to start working on a new tool chain and asks Lucia for a Kubernetes cluster. No big deal. Lucia spins up a cluster and hands it over to the engineers. As time goes on, more applications are designed to run on Kubernetes, so more and more engineers start asking Lucia for clusters. For their CI pipelines, for development and testing, for demos and workshops with their end users. Wow, this is getting out of hand. Should Lucia really spin up a cluster for each team? Or even more? One ephemeral cluster for each pull request? That would be hundreds of clusters per day. While scouring the web for a solution, Lucia discovers vCluster, a tool to create virtual, lightweight Kubernetes clusters, which makes dealing with multi-tenancy much easier. vCluster creates fully functional Kubernetes clusters that can run inside a single namespace of another cluster. vCluster is a certified Kubernetes distribution, so the virtual clusters behave exactly the same way as any other Kubernetes cluster. Lucia downloads the vCluster CLI and starts experimenting, spinning up virtual clusters on her local Minikube, and then later in a remote Amazon EKS cluster. Incredible. This was exactly what she and the platform team needed. Lucia is now only running a couple of large clusters, with a few shared services she needs to maintain, like an ingress controller. For everything else, she creates virtual clusters and hands those to the engineering teams. Inside the virtual clusters, engineers have full admin privileges and can do anything, autonomously and independently of the platform team. But they're still restricted to the virtual cluster, with no access to the underlying host cluster. That's amazing. And using vCluster has additional benefits. Virtual clusters are much cheaper than the real clusters. Engineers can deploy cluster-wide resources like CRDs or RBAC. Virtual clusters can be spun up and torn down within seconds. vCluster can run on any Kubernetes platform, including local clusters, vendor-managed clusters, as well as on-prem clusters, or really any certified Kubernetes distribution. Head to GitHub to learn more, or get started today at vcluster.com.
Okay, honestly, anything I say after this awesome demo doesn't even compare. Anyway, getting back to our presentation and using an informal speech, we can compare the Kubernetes cluster vCluster pair with a matryoshka. Does everybody know what's a matryoshka? This is matryoshka. Looks like Inception, right? The question is, what can we expect to find inside a Kubernetes cluster? And the answer is clear, another cluster. Basically, that's exactly a virtual cluster. However, putting aside the matryoshka analogy and reactivating the buzzword mode, we can refer to a vCluster as an independent Kubernetes cluster which is deployed inside the host cluster, which has an isolated control plane, and it leverages infrastructure sharing to reduce costs, as we saw in the previous demo. And don't forget that vCluster is open source and free, and anyone can use it for their use cases. In terms of architecture and components, a vCluster consists of several deployments that run inside the namespace of the host cluster. As we can see in this slide, it runs as a deployment, the vCluster implementation, and the stateful set, the etcd database. But since vClusters share nodes with the host cluster, how exactly do the pods run within a vCluster? And for this, Syncer component comes into play. Low-level resources such as pods and services are automatically exposed to the host cluster, and this allows the pods to be scheduled on the host's nodes. And this is a practical example to see the Syncer in play. In the first image, we are inside the virtual cluster and we listed a pod, an Nginx pod. Then, in the second image, we see that pod exposed in the host cluster running on the host's nodes. As I mentioned earlier, this is enabled by default for pods and services, leading to infrastructure sharing between the vClusters and the host cluster. In terms of benefits, vCluster is in the middle of these two worlds. It's a combination of a namespace and a cluster. When coming to use cases, I think that things are pretty straightforward. vClusters are really suited for creating isolated environments, taking advantage of fast spin-up time, which places them in the ephemeral clusters category. Another use case which is closer to real life is the following. For example, to build new Kubernetes clusters, we use some Kubernetes native controllers that will create cloud resources for spinning up new clusters. ACK and copy are among the most commonly used controllers for the task. ACK stands for AWS Controllers for Kubernetes and are a set of controllers developed by the AWS team for spinning up AWS infrastructure in a Kubernetes declarative way. CAPI stands for Cluster API and represents an official way for creating Kubernetes clusters by leveraging Kubernetes objects similar to the ACK objects. The right-hand side diagram shows how ACK and copy controllers work together. They run on the Kubernetes cluster, create custom resources, which will then be translated or reconciled by the controllers into AWS cloud resources to build new clusters infrastructure. And then, when we make a change in one of our ACK or copy controllers repos, for example, a controller image version bump, we want to test that change in an isolated testing environment which is as close as possible to the production environment. And this environment is the virtual cluster. But the most exciting things are just starting. These controllers will lead some AWS roles and policies attached to the service accounts, for example, for IRSA in EKS, that will give the controllers the permissions to create resources in the cloud. And by leveraging the power of vCluster Syncer, we can adjust those roles and policies from AWS to also match the service accounts exposed by the vCluster on the host cluster, as we saw earlier. Without vClusters, we were forced to manually test those controller changes in environments that didn't replicate production conditions. Okay then, now that we know the basics of vClusters and we established that we want to test some controller changes inside the vCluster, I think it's time to dive deeper into an end-to-end CI workflow, and later on, to better understand how are all the components connected between each other, we will also see a demo at the end. As we saw earlier, on a production environment, we start with the ACK and copy controllers deployed on the Kubernetes clusters. We will create some resources in the cluster, which will then be translated by the controllers in AWS cloud resources, as we saw earlier for that particular VPC. These resources will compound the infrastructure of the new cluster we want to build. Then, another two components come into play: GitHub and Argo CD. Argo CD ensures that the live state of the Kubernetes cluster matches the desired state defined in the GitHub repository. For pull request changes, Prow comes into play. Prow is a Kubernetes native CI system. It reports the running status directly to GitHub and runs the jobs on the Kubernetes cluster. And with all this being said, and having this diagram in mind, I think that we have a solid understanding of the key components we are working with, and we are ready to see how they come together in practice. In terms of pull request checks, we can define several pre-submit jobs in the style of Kubernetes pods. For example, for our vCluster CI check, we build a pod with a container starting from the Golang image, which executes a test script called test vCluster build. The script looks like this. It has several steps. First, to install some dependencies and build a custom written Go library that will allow us to execute some custom code for the cluster build workflow. Second step would be to create a virtual cluster, then deploy the ACK and copy controllers inside the vCluster by taking into account the change from the tested pull request. And then we trigger the cluster build process that will create the ACK and copy resources in the vCluster. The ACK and copy controllers will reconcile these objects and create the infrastructure and the resources in the AWS cloud, compounding the infrastructure for the new cluster we want to build. At the end, the integration tests are run to ensure that the cluster is functional, and if everything passed, we mark that pull request check as passed. Okay, now that we've covered all this foundational knowledge, I believe the best way to reinforce it is by walking through a real demo example. Great. Did the demo help a little bit to clarify the things better? Okay. Now, because we are getting closer to the end of this presentation, I would like to share with you a benchmark and draw some conclusions before wrapping up. We'll do a small comparison in terms of CI testing between vClusters and classic Kubernetes clusters. In terms of spin-up time, a classic Kubernetes cluster can take up to 40 minutes, while the vCluster is as fast as deploying some Kubernetes objects in there, as we saw in the host namespace, and it takes roughly 5 minutes. Then, as we observed, vClusters are really effective when it comes to infrastructure sharing reducing cost expenses. Another interesting comparison is in terms of scalability. vClusters are really good at running parallel tests, while with the classic CI, you need to have a pool of pre-built clusters which will be waiting to be used. And the last one, if comparing the overhead introduced by each approach, it's clear that a physical Kubernetes cluster needs a lot more resources and infrastructure compared to a virtual cluster. And now that we are at the end of the presentation, let's finally draw some conclusions about vClusters in the context of CI testing. First, we can state that vClusters are really suited for CI workflows, being isolated and scalable environments. Second, they are reducing costs while keeping the security topic valid. And lastly, if we manage to test such a complex workflow, namely building an entire cluster with ACK and copy controllers inside the vCluster, we can conclude that almost Kubernetes-related change can be tested inside a virtual cluster. And to make a final walkthrough of our journey, we have started from setting the scene of the CI testing problem and defining the objectives. Then we discussed about vCluster and its benefits, continued with a deep dive into an end-to-end PR testing workflow, and ended this presentation with some benchmarks and conclusions on the use of virtual clusters in the context of CI testing. And with this being said, I think this is a good moment to end up this presentation. Thank you. I think we are on time, so we can take some questions.
Yeah, please, questions. So.
Hello, first, thank you for the presentation. I have a question regarding when you should recommend using the normal Kubernetes instead of vCluster, because you talk more about the vCluster, and I'm wondering why it's not the default, and when it's better to use the normal Kubernetes stuff.
Yeah, are we able to put the slides back on the? Yeah, I wanted to put that slide with the benchmark. This says everything about this comparison, but especially a classic Kubernetes cluster is a lot heavier compared to a vCluster. So if you want to spin up a lot of vClusters or Kubernetes clusters, they're the same thing in terms of high-level preview. If you want to spin up a lot of them, it's a lot faster to spin up virtual clusters, and they simulate or emulate the classic vanilla Kubernetes clusters better. Yeah.
Okay, other questions? Okay, please.
Hello.
Hello.
Sorry, I'm not sure I understood what are sharing the vClusters from the base environment, like ingress controllers, I don't know, other resources.
Yeah, these slides, I think it's the best to keep this discussion about. By default, pods and services are automatically exposed to the host clusters. So basically, in a Kubernetes cluster, you can have multiple vClusters deployed in each of these vClusters in a separate namespace. So basically, the pods and the services from the vCluster are exposed to the host cluster, and these pods run on the Kubernetes host cluster. If you want to sync from the vCluster to the host cluster or vice versa, you can customize the syncer to do that for you.
Yeah, but the exact question I asked, ingress controllers. So do you need in your vCluster your own ingress controller or not?
No, you need only the custom resources. You can make use of the vCluster syncer to sync the custom resources from the vCluster to the host cluster, and the ingress controller can take your work and take those resources and manipulate them.
Okay, so you're asking vCluster to sync the ingress rules.
Yes,
okay.
Right.
You were saying that infrastructure costs are lower. Okay, I get it, but not necessarily too much, because you're still, I don't know, if your application takes 50 gigabytes of RAM.
Yeah, basically at the end, all the pods are running on the same cluster, right?
Exactly, yes.
Yeah.
Also, you mentioned security. well, namespace isolation is one, but for example, my pod running in a real different Kubernetes cluster is more secure than running in the same cluster where multiple vClusters are running.
The idea is that a namespace without a cluster role and cluster role binding is not like, it doesn't have security by default, a clear namespace, a vanilla namespace on the Kubernetes cluster, yeah.
Okay. Sorry, I'm having more questions. We're also actually moving, I saw the movie, right, the presentation. We're moving the request from the Lucia, or how was she called, from asking IT to build new Kubernetes clusters to ask for a new vCluster, because I doubt she's going to be allowed to build her own vClusters. Again, I know I see someone is nodding in here. It depends on the policies that you are adding in there. Like, if you don't do that, then every developer could start on its own 100 vClusters. Do you want that or not?
I think here...
It's rhetorical.
Yeah.
Okay, I leave to...
Okay, there are other questions?
Thank you for the presentation. As I understood correctly, if there is a change in one microservices, you will provision the whole cluster and the whole microservices. But isn't it too much and won't it take much time? You mentioned that provisioning takes 5 minutes, but I believe that provision the whole microservices, databases, message brokers definitely won't take 5 minutes. And in the end, we do change in only one microservice, and we want to make sure that this microservice change won't break. Do we really need to have to deploy all these other services? Did you consider stuff like mutation testing to see like dependency of services and deploy only those kind of services?
Yeah, for our vCluster CI check, we deployed only the necessary things, like the controllers, the ACK controllers, the CRDs, and other necessary dependencies which are necessary for the controllers to run, right?
Thank you.
Okay, other questions?
Hi, first of all, congrats for the presentation. And the second is, did you take into account kind, which is Kubernetes in Docker, which does something similar to vCluster and doesn't require a license?
Yeah, I think I had the slide for this. In this slide, I talked about the permissions needed by the AWS, by the ACK and CAPI controllers to create resources in the cloud. And I said that we have some AWS roles and policies in the cloud which are attached to the service accounts from the cluster, right? In order to create resources in the cloud, you need some AWS roles and policies to give the permissions to the controllers, right? And if we create an isolated testing environment without being a vCluster, like we said, a kind cluster, you need to create additional AWS roles and policies for these controllers in order to create resources in the cloud. But with vClusters, you have the service accounts exposed in the host cluster, and you can extend the AWS roles and policies. Like you can use a string like to user regex for that. And all the service accounts and the pods exposed from the vCluster to the host cluster have a clear pattern, like the service account name and the delimiter and the namespace and the name of the vCluster. Okay. So basically, using a string-like construction in the AWS roles, you can extend and give permissions to all the vClusters ACK controllers.
Okay, other questions?
Hi, thank you. So I had a question to better understand the limitations of vClusters. Is it possible, for example, to run a vCluster inside another vCluster?
I think you can do that, but it's not a recommended practice. Yeah, that I think is not a limitation. You can do that if you want, but
yeah, I'm thinking, for example, a scenario like you have a Kubernetes cluster for a team, and then one vCluster for each environment, dev, test, staging, and then vClusters inside that to run your jobs, such as CI and so on.
Yeah, but that scenario would be bad because I would have to remake this slide, this animation.
Okay. Thank you.
Yeah.
Okay, other questions?
Can you say a few words about monitoring and access to logs? How you are managing that, like permission-wise? As a developer, I want to see what my application will put in the logs, for example, or see, I don't know, I might be doing a performance test, and I want to see some metrics. And probably I shouldn't be allowed to see other developers' metrics.
So basically, for each team, you can provide a separate vCluster to provide the isolation you mentioned before, right? And in the vCluster, each of them, you can deploy the monitoring stack, and grab the metrics from there. You have Thanos, Grafana, or something like this deployed in the vCluster as well. Or maybe you can make use of the monitoring stack from the host cluster and only expose something like a Thanos service. And the monitoring stack from the host cluster will interrogate that Thanos service. So basically, whatever you have in the vCluster, you can expose or sync by the name of the syncer in the host cluster and vice versa.
Okay, I think we can wrap it up. Thank you, Iulian. Very impressive. I'm really enjoying also the vCluster for the testing, so very good job. And I think there are a lot of questions that the guys will have after this. We invite you to the lunch break, and after 1 hour, we will come back for the next presentation, the Infinite Hotel.
Yeah, sure. Thank you.